Hello and welcome back to another episode of Gifting Gadoxide. Welcome back, Sydney.
Hi, Sebastian.
And today I think we are taking another look at your work at pathspec, huh?
Exactly.
Yeah.
The progress made, mainly, basically working on those two checkpoints, checkboxes up there, on the error handling and on the attribute parsing. And both of them are basically implemented. The only reason that I didn't put a check at attribute parsing yet is because I guess maybe the code could be a bit nicer, the whole refactoring thing, but it's definitely working and functional. But yeah, I guess we can take a look today.
All right, let's do that. Session results. Yeah, let's do it when we get to it. I took like 10 minutes to check that out locally already and see why CI is not working. And then I pushed, and then CI started working again. Okay, nice. And I also noticed
there are errors.
That Windows is indeed failing for some reason. It's hard to see here because Nextest doesn't do a great job in kind of bringing the failing tests down somehow. And we can potentially take a look at this on the local VM to see what that is. Could just be Git because you're calling it directly. Could be something there. And we probably figure out what's going wrong there quickly. But fixing CI could be the first thing on the list to do, kind of, because that's always it should be green. And then I took another look locally. And when I ran the test, I was initially, I just shared directly with you what I thought. I was, what? Just two tests? And then I looked into it and realized that, of course, these are, testing on various inputs, and it's an efficient way of testing, and I really like that. But I think
a lazy way, I guess.
Lazy is good, really. Lazy is good because it makes it easy to test. It doesn't have to be more. I also started working on revision parsing here. And I thought that's cool. I didn't really think of it when I started it, but I thought I want to work on something that allows me to have little work sessions that allow me to make progress each time and that provide value and that don't run out of control. And the parser is always easy to do. So in a way, I could do it very much the same as you do for the most part, at least for the basic parsing part. But I ended up not doing that because of basic workflow considerations. And I think I will have something like this, but only once the parser is actually written. And my architecture is a bit different because it's kind of more complicated what the ref parser is ultimately doing. More complicated in the sense of state handling. It's different from what it is here. You are a pure function and you don't have to be more. So this is all there is. It's more like when it came to the way of working, I did first read the documentation and then I basically noted down all the cases that I think this has to handle based on my first read through. So I can tick boxes and can kind of focus on one thing or the other. And if you have this, then it kind of makes sense for me, and I'm really just saying for me in this case, it makes sense to revision lib. Oh yeah, presentation mode. For me, it makes sense to spell these out. Because
like basically organized by feature almost, right? Or
yes.
by certain.
Yes.
Yeah.
And right now it's not super structured. So if I run these tests here, it does compile surprising amounts of code just to run these particular tests. But unfortunately, the test suite references the Git repository crate, so it pulls in everything. So it's relatively unstructured because it's just spec parse and then whatever it is, but it's spelled out and it kind of helps me to relate that to what I'm doing here. And this is actually implemented now, and this is implemented, and this is implemented, and there's also some varieties of this. And it just came naturally. I think that the kind of for loop style, the what I call baseline style, you know, because you then have just a loop of stuff and you have certain expectations that you might compare to Git even, which I think you do. Then
yes, in the first test, yeah.
It also makes it all makes sense. It's more like if you have this reference as a baseline, then probably you will end up writing these individual tests and then really say, okay, this is what I want to test now, this is what I'm going to implement, nothing more. And then this is how you lay down by hand these little sticks while eventually writing these bulk tests that are, you know, potentially running the same stuff against Git. And maybe you're repeating yourself. That's fine. Or maybe you're just playing around with that more. That's also fine. But I think this is how it's going to be for this one. So for Git revision, manually laid out tests, potentially a bit more structured. I was thinking about structure, like adding modules. Would that help to have like a bunch of, you know, oh, this is for ranges, you know, and maybe these 3 top level parse items, so to say. This is really what ref specs are. They're revision, navigation on the revision, and potentially ranges between multiple revisions. So these 3 things, I think I can modularize now that I'm thinking about it. So could have some additional module structure here with my handwritten things to at least relate to these sections, because that makes sense from a structural standpoint, especially when you have this GitHub issue. If you don't have that, probably not, but yeah, that kind of offers itself here. Okay, but not to digress.
But I think it makes a lot of sense structuring these a bit more, because I remember for me it just kind of started growing. I started with a little test and 2 or 3 test cases, and then I just kept throwing new test cases into the same thing because it was easy and quick. But having a better structure and understanding about what can fail and how things have to work, I think thinking about that more will then evolve into more of a structure. And that's something I still want to do, like especially when you want to compare it to Git and to make sure it has the same features and it fails at the same points. It makes sense to give it a bit more structure than just 2 bulk tests.
Yeah, probably what would help you to kind of not let things grow out of control is exactly that you kind of force yourself to some sort of structure that might come from the documentation even, and then this might help if you found that sometimes you were struggling. If not, then, you know, you don't really have an issue, but still, I think the structure really helps. At least it helps me. That's the analysis part. Look how initially I said revision ranges are not part of it, and then I looked into it and realized, well, it has to be part of it. It has to be done now, and it's probably a good idea to do that now as well. Because, and that was also pretty, you know, first time I write it like this, I guess, because it's so kind of so well spec'd, this thing. But what was really cool is that the overall structure of the parser is super simple, but since I kind of do the, I don't even want to call it difficult, but because I do ranges first, kind of the very top level structure, I have to deal with the potential for multiple revisions right away. And that changed everything. You notice how the top level parser structure is already kind of structured so that it can handle that. And all I say is, yeah, I have to parse everything, and then it's a good parse. And this is giving you so many ideas for new test cases that you don't have written in your pull request task list, because, you know, it kind of offers itself just there. And then there's this playful interaction with Git from time to time that I don't have here as regression test, because I have that one level further up in Git repository. Git repository integrates with, or has to do the actual work, right? This thing just does parsing. And seeing this top level structure emerge so early is cool, because now I can imagine already how this will look like later when we don't only parse revisions, but we also parse navigation. And the terminology matches your description, your analysis, matches the documentation, and this is how the model of what a REST spec is really comes perfectly together in your head. And it all lines up. And that just reduces the chance for confusion to a point where I say, yes, working like this it's really nice. Like, it's just unexpectedly nice. And I don't know why I never really either noticed it like this or really set it up like this. Or maybe it's just because RefSpec is kind of simple and well specified. So I hope that from there, maybe, future work can also benefit to have experienced this. That's really nice kind of feeling.
Yeah,
Not that I haven't had it before, but this is really strong. This correlation between multiple parts of the same thing that makes things click even more than usual. And pathspec, maybe that's also one of these things that can work like that. Okay. Back to this. And now for the test, yeah. I mean, quick view. I liked it. Not much to say. I didn't really look into any details. It's great that you run it against Git, because some of these things they seem like something you would come up with while writing the parser. Or I don't know, where did you get these from?
Well, it was kind of, of course, while I was writing the parser, I knew, okay, this is a possibility for the parser to go through. But then, running those against Git, it doesn't give an output, but it parses, it doesn't give an error. So
okay,
you kind of have to compare where it goes wrong and where it doesn't.
Yeah, it's perfectly cool. And probably these things on Windows, I could imagine. Probably they have some issues there, the colon. Maybe. But who knows? I could imagine that Windows is a bit special there. And this should fail.
Yeah, this is just where I throw in basically some of the error cases and some of the things that shouldn't work. And this is by no means complete. Just another one of those collections where it could be easily split up, I guess, into multiple tests.
Yes. And I think it should, just because this to-do is not going to go away, I think. Like...
Yeah, I wanted to ask, because I initially set this up, but then I had to include the errors from Git attribute. And this doesn't have certain derives that I used, namely the equal derive, basically. And then I couldn't do these error comparisons anymore. So I know that we went through similar stuff like this in previous episodes, but I just couldn't find a good way to handle this, like if I want to just compare specific error types.
Yes. So here it comes. I think it's a test-specific issue to have that requirement of, or desire for, having equality tests for
Very true, yeah.
error types. And I think there could be, there could be something like this. You can say, oh, this is still quick error. That's strange. Did you add that? Or was this some leftover from somewhere?
Quick error?
Yeah. Am I...
No. In pathspec I added quick error.
Let's use this error. I think we had this conversation earlier. We together determined this error is the way to go. No more quick error.
I remember that, but Git attributes also uses quick error.
Because it's old, and wait. Let's check. Okay, it still uses quick error. Never mind. I thought I replaced it, okay, so but it should not.
The way to go would be this error.
Yeah, I mean, we said we port over older crates as we see fit, and the new ones start with this error, and it makes tests so much nicer, and it makes the interaction with the error type so much nicer. So this is why, IDE support, and it's just we tested that 3.5 seconds more initial build time, compile time. We just take it, we just do it. It's worth it. And that's just for the first crates who uses this error. So also it's not, it really is worth the price to pay. Okay, so definitely. I think that's one session outcome that we definitely don't do quickly. Session, how did I call it? Outcome or notes? Maybe in this one. results. Switch to this error.
Does this include get attributes then, or no?
If you feel like you want to have the exercise, be my guest. If not, that's also all right. Probably, yeah. I would appreciate it, of course, if you would do it. That's for sure. And if it's not too much, then maybe it's something you can just throw in. Okay, this error. So we were looking at errors, and I wanted to actually show how you could do it with just for testing. So you could say config error. There's actually no such thing like this. Config test, or should be actually. No, there is not. So you could say only for tests, I want to add derive equality, partial equality, and stuff like that. So quick error might not even allow that because it's a macro and it might not be able to parse this. I don't know if it can or not. This error will not have the problem. You can do it with debug assertions, I think, because that will work in integration tests. And this just means if anybody builds this with debug or in non-release mode, let's say in dev mode, then it will have these traits placed here. And that's as good as it gets. And this does not work because your crate is not actually compiled with this test. How do you call it? Attribute, maybe, with this test. Yeah, it's a compiler flag. You can set that on the command line, and it just sets this name. And this is just something Cargo does for us. But if you run...
It's like a feature flag, basically.
Yeah, but it has a real... Maybe it's a feature. Yeah, maybe it is a feature, honestly. Don't know the... I'm not super sure about the actual term now. And if Cargo builds your tests, then it just builds your crate with debug assertions, but it doesn't build it with this particular flag because only the test itself then has this flag or the particular binary that it builds with tests for tests. So anyway, this is how you could do it. And then you could use your the for loop way, which might be okay, I think that's fine. However, if somebody says fine, then it could almost always be better as well. And the reason why I think it could be better is maybe there could be some description that makes this a bit more obvious what, like, the error kind of already makes it somewhat obvious, but having one more name, the function of the test itself, might help to make it even more obvious what the problem is, even though here, like this invalid signature, there's a few tests of this kind. Maybe this could be more specific by having separate tests or some assertion text here. Maybe, but that's up to you. I think these things, they could be more specific probably because there's no special case here. Otherwise, for this, I think it's kind of obvious because the test makes the error itself makes it obvious. And yeah, this will look so much better with this error. I can hardly get used to quick error anymore. Now that I'm so used to that. Yeah. Okay. And you see this never elsewhere. So the alternative, of course, is these 5 tests, you just spell them out and you match against that.
Right. That makes a lot more sense, basically. That, split them up into their individual cases and then... No?
I mean, yeah, that's not the I agree thing, but the maybe some other. Yes and no, because equality is great because then you see the debug version of what it actually was. So if that, while it's breaking, it's clear why it's breaking. While it's breaking, it's clear why. But with matches, you only see true or false, and then you don't know what it actually is. Then you have to add some debug statements there, which is just time it takes. So please try to get it to work with assert equal.
That was a bit unexpected.
Ja, that's true. Das ist man total schockiert. Und ich habe versucht, mein Hotkey zu nutzen, um Pause zu machen. Und it kind of worked. Okay. 3, 2, 1. Oh, wait. Actually, it wasn't paused. Huh. I don't know what happened. Okay. Anyway, now it's recording again. So that can be better. Yeah, so you can try this debug assertions and see if that works with equal, because then I think overall you get the nicer error messages. I haven't done this anywhere else.
I think the only way I didn't do this in the end was because I was using the error from get attribute and I didn't want to touch any of those for now, just to keep it very simple. But True. That would have to extend to that error as well then.
Oh yeah, right. Yeah, see? And there it's not used at all, so it's really... And it feels a bit strange, doesn't it? Whenever you add something just for test, it feels a bit strange for all the right reasons. There's also complexity that is in your face, right? You kind of see that while you're reading the code, and you have to ask yourself why that is there. And so maybe that kind of, I mean, it's not used anywhere else. And I think that might be the reason, or is it? Maybe it is, but probably not, because I don't really recall. I usually use matches for this. And yes, I then run debug. Let's just say there's a cost to not having equal, but it's also so uncommon to have equality on errors, because in production code you just don't need it, that it's maybe something we just live with for now.
Yeah, I think so too.
Or it's temporary. I don't know. All right. Then let's just say use matches for error testing. Yeah, besides that, it's super nice that you have tests for these individual errors, of course. So that goes without saying, but if it's never said, it's kind of not there. So let's say it. And that's my 2 cents about, oh, what's this? Cache results. Yeah, maybe we can talk about this one too. How do you think this can be cached? Or
yeah, you basically, I don't know if there's some sort of, there must be some sort of, callback function or whatever hook that you can run before the test run or something like that. And then if a certain file doesn't exist, you just write the output of this function basically out to it for each test, and then just check it against it, something like that.
Sounds like good test tools needs an upgrade in order to do that. And that could be cool. This is why we want to talk it out and explore. Because I also thought, yes, it's kind of a super simple way of doing things, and I see why one would want to do that, even though it's kind of slow, potentially. I mean, on the VM, it was acceptably fast. Here, how long does a test take? Nope. Pathspec. Let's see when that finishes. I think I was at 0.25 seconds for this test. And this is, okay, no, it's 0.3. And this is really, really slow for what it does, right? Like this is all invocation overhead for Git. And I think it's acceptable. It's not even a second. So from
Yeah,
that
but
point
it's
of
only
view,
going to grow if I do add more tests, more test cases, then it's
but how much, also like really, I think it's fair to say, like, how many test cases do you see this will be? And right now we don't have a problem to solve really, except that, yeah, we are always depending on the Git version. So also all the tests that are there, they run Git at some point, like the existing test system uses this. So there's not an argument against doing this at all. And Git is quite stable and compatible also on Windows, even though we do have an issue there that we'll look into. My issue here is I don't think you can really test it, because this means you need one run that records what you're actually doing, and then you have to kind of keep track of the version of the file that generated the tests, and it could be multiple modules and functions calling each other, and like, good luck understanding the dependency there. In a simple case, this can be made to work, but if you go any more complex, you've got weird bugs with this file not being updated, or even if it's not updated, you could say, well, then we just run the program. It doesn't have to fail, it can just update itself later, or do stuff. But it sounds like it's it's quite a thing to do, and right now I wouldn't even feel motivated to do it with the performance that we have. Another thought would be, can we use the existing tests framework to do that, like just having a fixture script and then writing out these test cases? And to me, the answer is somewhat yes. Somewhat, in the sense of, sure, you can write this into a shell script and you can run Git against it, and you can probably also, in some shape or form, write this and then parse it back. This is basically the mechanism. And then the source of truth is the shell script, and the shell script is automatically run only when needed. And, this is as fast as it gets. And you only have to parse back that baseline file that you create, or that file that you create. Do that make any sense? I can show an example.
Yeah, that would be cool, just to be sure. But you're basically saying that the input for the tests lives in some other file, and that would have to be passed around basically based on where it should run.
Yes. So it's a bit more convoluted than I'd like it to be, this one, but I think, wait, git glob also has a baseline. That's a better example here. Yeah, that's better. That's cleaner. So in your script, you have some sort of description. In this case, there's some file, some indoc file. How's the term again? Yeah, one of these that are files that you can pipe to std in, and then this reads it line by line and does stuff to it. So in this case, create 2 lines or 3 lines. No, I create 2 lines. And what this does is reads this indoc here in the bash file, and then it outputs some results to this baseline that it says no match, match. And this baseline file, it consists of the pattern and the value that you're matching, so this and this, and then the output of Git itself. So this is how you have the input and the Git baseline in one simple file format that you then later parse back. And this is how I do it for all kinds of baseline tests. And this is how you can just, run Git once here, record its output in some way, and then you parse it.
And you run this manually, basically, whenever something changes.
No, yeah, right. How is it used? Let's look at it. I think it's, yeah, where's it used? Make baseline glob, maybe wild match. Yeah. So you use it like this. So there is this function in Git test tools that says scripted fixture repo read only. And that one executes the baseline script only when needed, and then the output is considered read only. Thus, you can just use it again and again each time you run the test. And if your one file changes, then it will rerun the script entirely and generate a new output. And it does all kinds of cool things. It also archives that directory that it creates, and it allows itself by default to reuse it on Windows, for example. So Windows doesn't have to execute this anymore. So if if we see that Git kind of works strangely differently on Windows and we don't want to support that for whatever reason, because maybe it's a bug or it's something we're not interested in, we can use this capability to just generate this file on macOS, Unix, and have it be reused.
Same.
Yes. But for now, I would say let's not do this. Let's look into it. But by the way, last thing, it creates these archives and you can add them to Git using LFS, but only using LFS. So LFS is configured for these files here. So you see everything that is in test fixtures, in generated archives, and that is looking like this. You use git LFS as filter. And that works well. That works well for me. And these files are then reused automatically. However, if you don't want that, then you can also just use, how do you prevent things from being used? I asked myself, well, it's as easy as git ignore, right? So you just add the file that you don't want to be in Git, you just add that to git ignore in that particular directory, just put it right there in generated archives or something. And that way Git will ignore it, but also Git test tools, they've got some crazy skills. So this crazy code here, this generates a work tree cache with access to the ignore stack. And this is how you are able to, how this system is able to check git ignore to actually not even generate archives anymore that are ignored. Also not try to use them. So this is how that system works and how I use a capability that was just recently added in an actual tool. Okay. So that was cool. And
that seems pretty convenient.
Yes. That's the thing. Now that you've got programmatic access, that's just, you have to go through the pain to eventually make these APIs nicer and nicer. And this doesn't use Git repository. I force myself to use plumbing just to see once again how this is. And how that feels like. And it's tough, but it's doable. It's just a lot of state that has to be created here. That's why it looks so complicated. But nonetheless, this already shows how cool it is to use Git attributes and Git ignore. Because also with Git attributes, you can drive your entire tooling for whatever you have in your project. And you should. That's it's so powerful, this thing. It's more likely much more powerful than anything you would come up with yourself or that you already have. And now it's more easily usable, let's say, at least if you have Rust tooling. Yeah, so that was cool. Anyway, so you see, back to the baseline, this is how you use it. This is a baseline parser that really just is the cheapest possible I unwrap, I expect, I don't do any error handling kind of parser that parses the values back based on a well-known file format.
It parses the values back from the fixture file itself, or from...
Let's see. So there's 3 input files, and it just reads these. Get baseline match, nmatch, match icase, and you see how they're created here.
I see. Oh, I see. So you create the input file with this shell script, and that is then being read in the tests.
Yes.
That is smart. Okay. Yeah. That makes sense.
Honestly, I don't know if it's smart. It just uses the capabilities that are there, and it makes it easy to just bulk run Git against stuff. And this is just a cheap version that doesn't even, while loop and so on. Sometimes Git allows to actually take a bunch of arguments, and then you can just dump it into Git and see the whole thing. It's just, this is fast, it's easy, and just run once, and that's the key. And then you just can scale to whatever. And there was one test that ran like 2 minutes or 3 minutes on Windows because it was really running Git a lot to generate a big repository. And this is where the archive idea came from, so that it writes these archives and they can just be quickly extracted on Windows, so Windows doesn't have to take 2 minutes, but instead just a couple of seconds to recreate the state that you need. And with this system, I think you can really have fast tests and simple parsing of simple files that you completely control. It's easy stuff, and it's totally worth it to me,
Yeah, I'll definitely take a look at this. I mean, I'm not technically matching against a specific output in my case. I'm really only checking if Git errors or not. So I have to see how I can encode this, but I'm guessing it's probably also then just like a parsing question.
Yes, it's right. It's an encoding question. How do you want to represent a failure or success? And it's all up to you. Whatever is easiest, I suppose, because you don't even read these files you don't read them manually. Just parse them back. And this is how you can resolve this issue with the current system. This is how it's done before. And this is how I will keep working, because it's okay. It's not the worst thing in the world to use Bash for that. And it comes with many benefits, as stated earlier. And since you have a baseline, it kind of makes sense. But honestly, if you think you can solve this problem of potentially speeding this up, fine. But I think it will be, like right now, I think it will be involved to persist this across runs and make it work really well. And it's not really, I think for me, there wouldn't be enough payoff to do it. Not for these times.
Yeah, I mean, this is what Git test tools already does, basically, right? I mean, you have to set it up in a specific way, but it already does this whole persisting job and the automatically updating, and that's all included already. So all functionality I'll just reuse.
Yes, and at some point, it spits out locations as well. So you can that's the cool thing. You can run the script. If it fails, it will tell you where it failed and things like that. It's quite nice to work with. And it will leave the state untouched. So you can cd into there and you can look at what's there. That's how I usually debug this or have a look. And I just check it out manually from time to time until I know what's going on. And then eventually the test is working. Yeah, okay. And then this to-do would also be gone. Cool.
There's one more in this file where there's more of a question on how to handle this. It's a bit further up, and it's basically this. It's very specific to pathspec, but there are basically two magic signatures that cannot occur at the same time because they semantically just don't work together. And the question was if it's the parser's job to flag this, or if it just should parse it regardless, and then pass it on to the next one.
Yeah, it's a great question. We have pathspec and we have pathspec matching. Pathspec parsing and pathspec matching. And the matching, I don't even know how that works entirely, and I have no understanding yet. I think at the latest, when you try to match something with incompatible flags, then this would fail. And with pathspecs, the next thing is how we would use pathspecs in the code base. And to my mind, if we would have something like index add, like git add, we'd want to add stuff to the index or to the work tree add. We want to add stuff to the work tree, or I don't know how the API would look like. Then this would probably take an argument that is a path spec, or a vector or a slice of path specs, because you can always give multiple, right? So we can probably And you can also do negations and stuff like that. So all that should be possible with the API. Hence, probably a vector of these path specs. And then this would, like, it would probably be, wait. I mean, the parser's output is what again?
It's this thing called a pattern, yeah.
Pattern.
That basically just collects the path, the signature, and the attributes. And if it finds, like at the moment, it just gets through all of the attributes, but it could flag if these two incompatible attributes, if it finds those two incompatible attributes already here, and then result in an error, or it could give it back up to the matcher. Yes. But I don't really know what they would do with this information, so might as well just fail at the parsing step.
Exactly. It's more like our API would then have to have an error somewhere that says matching failed because this was actually an invalid signature. But then again, look, this all pub, people can just create this themselves, right? Right now they can. So this is not a this pattern is not always valid. Even like the parser might generate a non-valid pattern right now, but also the user. And here's the thing. It all boils down to where the error is handled. And right now, since every API user can just create an invalid signature without problems, I'd say the parser also creates potentially invalid signatures, and that is handled at matching stage. Or you find a way to prevent invalid signatures from being created, which probably means that these bit flags are, I don't know, if it's bit flags, they're all open and they must be freely combinable. But which two things are not combinable here?
It's literal and glob.
Literal and glob. So maybe if these would be pulled out and be put into an enum, then you can just represent them differently. And I think in code, it doesn't matter, like in code, you can always, when somebody's interested in, is it literal, they can always match against, I don't know, maybe it's just a bool then. Or, whatever it is. But I think it's okay to pull it out. And then you have two signature fields.
I was thinking about this anyway, like how would you use these bit flags? I mean, I used them because it was kind of obvious to be able to combine them, but I don't know how it looks on the other side. How would you match against them? I haven't looked at that part yet.
Yes.
So maybe it's not even a good or convenient idea to use these anyway.
Actually, it is.
It is.
Yeah. Like, first of all, you don't want an option here, I think. What you want is just, these can be 0.
Yeah, okay, true.
And then an empty signature is nothing. So that would be that. I'm also not going to change this now.
That makes the code a bit easier, yeah, true.
Use magic signature without option. And in code, it's very convenient to use this. And I think it doesn't make a difference to have an enum for the things that are not combinable with everything else. And bit flags make perfect sense. It's a set, it's a bit set essentially. And that's how you can use it. It's really powerful, it's convenient. But when it's not a set, but different variants of the same thing, then mutually exclusive variants, mind you, then it should be an enum and you can just make it like this. And this answers the question as well on how to deal with this case here. Huh? This means this would not parse.
Represented in the...
Can't be represented. And this is beneficial for us. Now nobody can represent an invalid state for this. Can they? No, I don't think they can. Cool. They can, but probably it doesn't matter because attributes, they're also type checked actually. Attributes, not every attribute name is valid. And there is a function somewhere that tests for validity of attributes. Are you using this? Did you manage to use this?
I'm using the get attributes crate completely to parse this, yeah.
To parse this. Great. Because this is maybe a shortcoming in the get attributes crate because it is validated that this is a valid name, but it's not type safe. Hence, this could be invalid. And the path, well, it's just some path, and I guess it's fair to say that this might be anything and it matches or it doesn't match, and that's it. Okay. So this is more like, honestly, since you find it, it's something you could look into and see if it makes sense to have a validated version of an attribute name. It shouldn't be too much work, I think, because Git attribute parsing, it's just the parsing that is implemented, and I was maybe too lazy or didn't see it as an issue. That I just didn't see it as an issue, but I think it is.
But you mean validated just to be able to exclude certain words, for example, or just have some sort of restriction?
Could the attribute name use the same idea as used for full name in GitRef? So this is the same thing. It's just a B string owned, but you can't access what's inside. And this full name, if somebody has this type, it's guaranteed to be valid name for a ref.
I see. Okay.
And then you can interact with it in specific ways. And whenever you have this, it's valid and you don't have to revalidate it. And that helps with, again, it's one error less to handle when you do the matching, for example. And it's also avoiding some silly mistakes that otherwise could happen. And this is why it's used in GitRef the way it is. And I think it should be the same in Git attributes. You could have a look and implement this. If you think it's not too much work, I don't think it will be too much work. And you can just implement what you need and nothing more, just don't predict anything. This is really just a parser, and it definitely validates I think it validates the input. If it doesn't validate the input, yeah, I think it should. So yeah, take it with a grain of salt.
I'll take a look.
This assumes that Git attributes parsing validates attribute names, which I think it does. I think it does that. Okay, cool. And then we have only valid things in the pattern, and that will facilitate matching. Cool. That's the last question for today, huh?
There is actually one more, just a quick one maybe, and that actually relates to how I'm using Git because I'm really just using, I think, creating an iterator from Git attributes that just runs through, and in there is a concept of lines and line numbers. So when I just propagate the error messages don't really fit because it's talking about lines and that doesn't really matter in this context. So I guess my question is, what is the best way to handle this if I just make custom errors for all of these cases, or if there's an easy way to give it a different display, basically, or just modify the existing one? Not sure if that makes sense.
I see. I think I understand. So this is a line-based iterator, so it really has the notion of lines built in, but here it's always line 0 or line 1.
That's probably a bit of a hack, but it works.
Yes. So which line are you? So for me, this is a convenience that it knows the line number. Yeah, after a break, I don't know what I said before, so let's clear this up. Okay, this must be confusing, but it's just as confusing for us. So many breaks here, but I think we were talking about the line number here and how it kind of is a fake and it's showing up, and that's the worst, right? It's showing up in the error because
exactly.
It really wants. Yeah, so the reason this is the case is that
I mean, I'm not questioning the use of the line number for the Git attribute parser, but it's just
but you should
want
to
be
question
those
everything.
Errors, if if I would like to reuse those errors, then I can't reuse them as they are. And I was just wondering if there's a smart way of kind of reusing them with maybe changing just the display, or if I just really have to recreate them and basically make them custom error messages.
Yeah, look at this. The only potential for errors here is attribute name, I think. Like what errors can actually occur? Here, check error. So does validate its attributes. That's answering that one. And look, the only error that it actually produces is attribute name. So I think in this simple case, I mean, sure, this could change, right? That you now become dependent on it, but also I don't think it will change. So yeah, you could match on that and then transform it into your own error. And yes, here's also where you would then wrap this attribute name into something else so that it's clear that it's a valid attribute and nobody else that doesn't live in your crate can create these attributes just by instantiating them, you know, because it's private what's inside. And this is how you can have validated attribute names. And maybe that's also useful later when you do additional stuff with attributes, or I don't know, probably not, but something you can do. I think the reason I didn't do this right away is that I wasn't sure how these attribute names are actually used later. So I pushed the can down the road, essentially, knowing that I will take care of it, but for now there's no harm in basically storing the information that it's valid in a type. That's what you're doing. And we can let that grow from there if needed. Otherwise, I don't think it's a problem to have. Cool. Yeah, great questions. I love them. So then we have a new crate here.
This was just kind of trying to module. I mean, it's not really functional much more. It reuses a lot of the stuff, but it's a bit more concise, I guess, and a bit shorter than the previous one. Also, there was one extra error case that came up from this one kind of automatically that I couldn't really reproduce in the other one, now the old one. So yeah, I'm kind of going with this one now.
The old one. So this was two different parsers, or?
Yeah, exactly. Module to be able to compare them a bit better. Yeah,
that's cool. No, that's exactly the way. I like it. I think from a consistency perspective, I would. Is there can I call this from bytes? Probably yes. Huh? There is no function that is called like this.
Yeah, you should.
I remember the previous style. Yeah, there was this parser, right? And it's kind of
exactly
a bit stateful, but maybe it was stateful, and now it's not anymore. This is why the functional name came in. Okay, I remember now. Okay, and it doesn't look worse at all because
it does a lot of the same things. Really, it's just here and there it's quicker. For example, here I use the split function, where before I had this weird thing of looping through and then having those two buffers, and yeah, it was a bit awkward. This one is a lot more easy.
Yes. That's interesting also. It's actually doing a split, right? And I didn't see this either, even though it was kind of clear, but I didn't question it, right? So that was good. I just thought on a high level, how can you optimize the buffer usage, but I didn't think what it's actually doing.
Yeah, but it's also the way how the data came in, because it was in an iterator, so the split wasn't so obvious. So I had to rewrite a bit of the previous stuff, but yeah, this one is a bit easier.
Yes, see, so don't jump to iterators unless you have to. I also, with the parser I'm doing now, same thing. I stay in slice world because I have it and only do anything else when needed. And probably I will just keep using slices and just have little functions that do special things if I use them more often, something like that. And that's helpful. But yeah, totally. Use what's there, use what's available on that B string or on that input slice of your 8. I think it's fair to move that back to parse Or
absolutely.
if you don't want that, you know, it's already big enough. I think 155. You can also make a sub module here, but then you would
I
refactor
think
this.
pretty much everything in parse can be replaced anyway by what's in the new module. I think it just still has the correct errors in there.
Okay.
But yeah, I will consolidate those into one.
Good. Also from a pure look, I didn't even look at this yet. It looks good to me. I like this. That's exactly the way. Oh, that's so much better. In my code, I wrote this.
Oh.
So I'm gonna change that. Sometimes
there, right?
sometimes you're not, and I know that first exists. I just don't really think of it when I think of strings somehow. Okay. Anyway, makes sense. It's there. Use it. Great. And then you have.
And this one, I was fighting a bit by bit, but I'm still using this while loop and this cursor approach now, which is very similar to the iterator, but the way that these can be combined, it's still very convenient to just loop through these and check where we're at the moment, because you can't really split those easily. So the looping is still an easy way to go here.
Mm-hmm. So, yeah, and this is where you change your offset essentially.
Mm-hmm.
So that the loop continues here, wherever it's unconsumed. Yeah, that's interesting, because I also think, it's perfectly workable, and I like that so much more than it was before.
Mm-hmm.
And since you it offers itself up, I think there's no reason not to do it like this. The end here, oh yeah, right. You parse it differently now. You find the first closing parenthesis and you just find it. It's look ahead. From a parsing perspective, you look ahead, find it, and because that is not recursive or anything, you can just do it like this. And it has to be correct, so to say.
Yeah.
Something that you should definitely put in here is some assertion that validates that you parse everything. Like there should be no leftovers, right?
Yes.
No, wait.
The way that these things work is, the magic signature is always in front and the rest is just path.
The rest is path. Yeah. Okay, never mind then. Then there's nothing to be done here. Also, new line and white space. If Git doesn't trim it, and if Git doesn't do anything special with it, this is always what I'm thinking about. Like white space trimming, yes, no, and what does Git do? And you have the setup for that already. I would probably have some extra tests for that just to validate that it's really not doing anything special with white space or new lines, crazy things like that. What about white space in path? I know the prefix of the input is kind of sensitive to white space, so you would trip on that already, but the suffix there, the path, might be interesting.
Could be anything, yeah.
White space in path. Trailing maybe.
This also kind of comes down to how you use that path, because essentially this will be parsed or expanded by git glob, right? This path portion. So I don't know how much of that is already handled there. Yeah, but I would imagine
it doesn't care. It takes everything literally. It really is super lenient. It's more like, also, I don't know what's right. It's really Git says what's right. And as long as you have these tests, just to be sure we understand that and that we implement it correctly, that's all. It shouldn't trim. I wouldn't expect it to trim, but maybe it does, and then we have to do it too. That's all. Yeah, so I'm loving it. I also don't know how to do it differently, to be honest. There's one thing that I can think of, but I don't even... I don't know what's better, really. So since you're consuming the cursor here, since you're consuming the input, you could also do something like next byte or something like that, and you give it the input then while let sum byte b, and then the next input. And then this function just takes the first byte and then slices the input so that the first byte is skipped. And this means you don't have to do cursor handling anymore. This means here you would only do this. And here you would just do this. This is a consuming version of writing what you are having here. Because you literally consume the input slice and you reassign it. So you cannot accidentally do off by one thingies or whatever. You can't. It's impossible because you cannot access the previous input anymore that you consumed. And for respec, this is how I'm going to write it, because this is also how nom works. Like nom always slices whatever it parsed off the input and returns the rest. And
what about this one case where I do have to go back one? Because that was also the limitation with the iterating version. Yeah,
you do have to go back.
Sorry, a bit further up in the last break in this while loop here. Yeah, there's the
right.
cursor -1. Yeah, and so I need this capability of just not consuming there basically. And yeah, I guess it's a bit. You could still do it, but might be a bit more lines to write.
That would be more lines to write, because then for each of these statements where you want it, you would have to consume. Now we have to consume. Give me the next, give me the next. And the alternative is that you make it so that you're able to put that back somehow, that you keep the previous version of it, and then instead you say input is previous input. And then at the end of the loop, you have to kind of, that this would also be an option. This is the way to consume, but roll back to a previous known state that is always the previous character. And that's the alternative. I don't even say it's better. From lines of code perspective, and also complexity perspective, it's probably more than it is now. And this is why I would even say you have unit tests, massive amounts, that's all we need. And there will be more even, right? So it's good that way. Oh. This is why it was from bytes functional.
This is true. The other one still exists.
That's not used anymore, right? So I can just remove this for now. Oh, okay, now nothing is used anymore, and I'm opening the box of Pandora here. So
next time this will be neatly consolidated.
I mean, consolidation what would that mean? It would just mean I copy one in the other.
Almost. You can copy everything from parse functional. And delete everything but the error, basically, from the previous parse.
Good. So this stays.
This stays, and yeah, this should probably do it.
Oh yeah, that was the previous version. I think I messed up. Let me try again. Now I actually pasted that.
Oh yeah, the import.
Yeah, right. We already import that.
Oh.
And we have that already. Now we only fit 4 lines
okay.
of code on screen. That's funny. I think this is a new one. I don't know why there are 2. I don't get it, really. Did I not delete all of that? Oh yeah, it's still here. Good, makes sense.
Oh.
Good. Tests are still working. And it's consolidated.
Cool.
I just call this refactor. Okay. That's maybe not the best commit message ever, but it's good enough. And here we are. Yeah, that was really just a quick look, but I think we have enough for today's session in terms of potential changes. And it's really interesting for me, maybe for a wrap-up, to see this style in the sense of, okay, I need to backtrack one. Can I do this, and how can I combine these capabilities with each other to write the least amount of code? And it's all trade-offs in the end. But I really like the trade-offs made here because it somehow yields very readable code that I think it's also safe, easy enough to implement, let's say, in terms of what's going on. And that's really neat. I do really love my consuming iterator, but once you have backtracking, I think it complicates things.
It's annoying. Well, I'll give that a try for sure, because I also don't like this cursor idea. We'll see if that feels a bit nicer, maybe.
But, I think it won't. I mean, I just tried it, right? I spiked it just now, and it's already obvious that it's going to be more complexity. But for what? Just so that you don't have a cursor, essentially. And to me, that's not worth it, because that's also so nice and clear. Oh yeah, we go back one.
Yeah, that's true.
And it's just neat. Okay. Anything else that pops into my, or that pops out here? Yeah, here, this one. So that's the intention, no?
Yeah, exactly.
Okay. So here, because once you write starts with and then this, actually you want to strip a prefix. And then you can try to strip a prefix. This does not, strip prefix doesn't really combine well with these if conditions because they have to be Booleans. But to me, this would just mean I would rewrite it like this. Yeah, geez, syntax. So let's see if I can get this together. Not quite yet. Not quite yet. No. No. Okay, not there yet. No, no, no. No.
Oh, there we go.
Now it has it. If Rust FMT can indent your stuff, it's probably not too bad. So now you can do if let some attributes, I guess. Strip prefix adder, and then we go with attributes. maybe into. No, this is already a variable
okay.
here. And oh,
yeah, this is probably a very backwards way of dealing with this.
is it?
I don't know. It feels strange, like mapping a list of attributes to one outcome, and on the way, just
As a side
doing the
effect.
output somewhere else. Yeah, exactly.
Yeah.
Feels like it should be cleaner.
Yeah. But you also want to handle the error.
Mm-hmm.
Yeah. Well, that's true. I mean, generally these side effects and maps don't. Unless it's really, I'm counting stuff and I have to do it like that. There's no other way. But then if you want to count things, you do inspect. Because inspect is kind of made for side effects.
Mm-hmm.
But generally in this case, you really just want to get rid of this.
Keep the error, keep the vector, and then I need the correct return value.
Yes. So we have the value v in here. And we just error out of this, right? And then we assign v to attributes and we do this. Is this already formatted? It seems like it. And that's clearer.
Yeah, it's a lot clearer.
But it's a pattern too, huh? So next time you see this pattern, it's basically just avoid the side effects and you can always do it. And then you basically get the solution, so to say, automatically. And that is that here. Everything else seems pretty clear. Nice. Reassign this. Let me try something. Whoops.
That shouldn't happen.
I actually didn't expect this to happen, to be honest. I thought you must have a test in your many tests that tests for multiple of these attributes.
Yeah, there is. There should be at least.
Yeah, huh?
Maybe it was this one. Okay, yeah. Maybe I only
this
had
one
this one
test.
test that tests all of them.
that isn't that isn't there yet. Yes, right. That is commented out. That one was that one.
True.
Okay, never mind. This is why I thought it shouldn't happen, huh? Because it's there. Okay, so that's a refactor.
Yeah.
And we have
the only one that tests for multiple.
Yeah, but it's gonna be there. That was the to do. Let's see about this. So then we have the result. We map from within the result.
Yeah, because this gives me basically the referenced version. So this is a state ref and a referenced B string basically, and I have to map to the owned version.
So let's try something. I mean, that's pretty clear and all. It's more like you can possibly leverage. Like, I don't know, it's probably about style. Like, this is fine and it's speaking to you. It's making it obvious. Sometimes I feel it's not so necessary to make it obvious unless the compiler forces you. So let's see if the compiler forces you. So compiler's inferring this neatly. So then I would probably prefer the smaller lines, also because this kind of
Just make it obvious up there.
Yeah. Honestly, if you would say I like the other one more, I would revert it.
I like this a lot more actually. I don't remember fighting with the types a little bit, and just on the way there, having it really explicit helps. But once the solution is there, it makes sense to shorten it down.
Yes. So you see already, like, okay, why am I not doing this? And Yeah, I think that's as good as it gets because we have to collect first in order to get rid of that result.
Yeah, and this whole mapping inside of a result, was there a better option? Because you have these two maps there, basically. I thought maybe there's a smarter way, but also maybe not.
Could be, but only if Git ignores errors and attributes. Maybe you can check that. Like, I don't know if it's in code or if you can just validate it. What does Git do? Does Git ignore or does Git die? I think Git would die, but maybe it doesn't. And if Git doesn't die, then we probably also don't want to die or error. And if you don't want error, then you can just filter it out and then it's going to be much easier.
Yeah.
But I think it will do exactly as you do. And probably this is the kind of thing I would look out for. Like what does Git do? Just validate it quickly, and you already have auto validation with Git, right? So you can just make sure you have a test case for this, for the error case. And
this would really be the next big step. Like now that everything's up and running, just really try to squeeze out all the little test cases and see to get it right, basically.
Yeah. And while you're writing this is something, to note down maybe, or to write an ignored error for so that you don't forget. And that's all. Like I prefer ignored errors for this, and that's usually how I work. I just dump them and then eventually I will implement them.
I see.
And that again kind of brings you to, these manual flagpoles that you put down during development. They're useful. These baseline tests are also useful. What to use when. So I start with these manual flags usually. I mean, in this case, every case is different. Then, yeah, nothing else. Looks great, and so much better than before. It's incredible, and that's to me. That's to me already the work of somebody who knows Rust really well. Like. I couldn't do it better, and it looks very, very neat, so to say, and it will look even neater once there's this error here. And yeah, I think Clippy also.
Yeah, I have to run Clippy more often. Keep forgetting. It's probably trying to complain.
But maybe not anymore, because Clippy was complaining about the old test, not about the new ones. So never mind. I know I saw Clippy, but it was the code that is now removed, so that's great. Yeah, I think that's it for our today's session.
Pretty cool. Thank you very much.
And I thank you for the great work that you're delivering here. I'm really happy about it, and it's fun to do these sessions too.
Absolutely.
And when I'm done coughing, I hope to see our audience next time for the next episode when we are reviewing pathspecs or anything else. Have a good day. Bye-bye.
See you soon.